Okay, the very first set of tools that you need to know about are, they deal with wire. And you need to know these tools so you can cut wire. All right? So these lovely little babies, these are just channel lock wire cutters. They work great. They're not precision tools. This is just to hack off a chunk of wire, right? So we've got a piece of wire, and you're just saying, I need an inch of wire so that I can then go make something out of it. Then you just cut off a piece of wire. And what I'm saying here is, when it's time, like, to see the end there, see the end of that wire? It's like it's smashed, okay? That, in contrast, is the next tool. These are flush cutters. And what I mean by this is, if you look at this side, you see how nice and flat that is? And on this side, there's quite an angle on the cutting surface. So if I take a piece of wire and I cut this right here, I'm going to put this back here so I have kind of a white background. On this side here, you get this really pointy surface, but on this side, it's nice and flat. You see that? That is going to come into play. You get this little line right there, but that's going to come into play here in just a second. That's super important to know. Okay? If you're using these flush cutters, you're using the flat side. That's what you're worried about. Because what's going to happen is, when it's time for you to do your wire soldering project, you're going to use the flush cutters, and you're going to cut this little triangle off. You'll sand and file those, or file and sand those edges, and then you'll solder this back together, just like this, so that you know how to do that. You need to have those pliers, or not pliers, these cutters figured out so that you can do that. So these, super valuable. I've got about 6 pair of them. That's plenty, okay? These, something that you want to be aware of, they are not meant to grab a hold of a piece of wire and then bend. That'll break them. They'll quit working, okay? They're not meant to cut big giant stuff. They're just meant to just simply cut the wire straight across. Okay? Everybody good with that? The next things. All right, Christian, where'd you go? I want to show you how to straighten a wire. So we're going to take this out of this. You're going to follow me along around here, along here, and cordless drill, right? This wire is very much not straight. And what you're doing here is you're just putting this in the chuck. This right here is called the chuck. Tighten it down so it's just right there in the middle. And if I were to run the drill, you can see how not straight this thing is. Okay. Well, what we do is come over here to the vise. You put one end in, you tighten it up, and you go slow. Doesn't matter which way you spin it, but spin the wire. Tighten it up, and look. It's much straighter. You can kind of look down that with the camera, and you can see how straight that is. You can see that wire nice and straight. We'll use this more in just a second. Let's come back over here now. The next thing I want to show you is called the shear. We'll be looking at this. And turn the light on. It might be easier for you if we just flip this over, because then the camera is up here instead of down below. Holy cow, flip it back the other way then. That'll be fun to watch. Sorry. Okay, this is a shear. And it's like a giant scissors. Okay? This is the handle, like this. This is open, this is shut. So I've got a sheet of copper right here, and I'm going to show you how to cut it. So if you come over here to this side, this right here is the fence. Right here, this is a ruler. Right here is millimeters, and on this side is inches. Just pay attention to the millimeter side, because that's what we use, because they're so much more accurate. Now, say I want to cut something to 35 millimeters. So what I'm going to do, let's see if you can get real close to this. Right here, oh, somebody took my wire. 1 centimeter, 2 centimeters, 3 centimeters, that means 30 millimeters. 35 is right there. So if it's down here and I just move it out like this, I may land on the right one, I might not. I always like to go bigger and then work down smaller. Now, the important thing about the shear, I get this where I want it to be. Take 2 fingers and raise this up until it stops, and that's all. Okay? If you guys force this, it's really old and it's the plastic knob. You'll break it off, and then I'll break you, okay? All right, don't break it off. I'm really not gonna hurt you, but you heard me say it anyway. So, you're not forcing it. It locks it in place, okay? So now let's go to the other side. So now what I can do is I can take my piece of metal and I can push it, I can open the handle, push it in, and it stops at that spot, and then crank it over and back here, move the fence, and there it is. And if I've done it right, 35 millimeters on the nose. Good job. There's hope for me yet. Yeah. But I'm going to cut a square. So I've got it back to 35. Take this, put it back in here, crank it over, reach under here, and now I have a 35 millimeter square copper piece. And then my scrap, and that's the piece that I'm going to use next. Okay, I'm going to use this now. I'm going to come over here. This right here is called the arbor press. It is a 2-ton arbor press, which means it will create 4,000 pounds of pressure potentially. I've not tested it. It does what we need it to do. All right? I'm not sure how I would test that actually. But this right here is a little polymer pad, and I'm going to show you the disc cutter here. So this guy. All right? This little block of wood keeps everything nice and organized. The little polymer block lives back there. All right, we're going to put that right here. And this right here is what makes the disc cutter do its thing. This is like scissors, only it's round holes instead of straight lines. And you can see through there, you see down in there, there's a gap. And it closes if I tighten this. And if I open it, you can see down through there. All right? If I take my piece of metal, say, let's cut a 1-inch or 25 millimeter circle, right? Can you see that, Christian? There you go. So I've got this in here. But if I just tighten this down, we're creating a giant problem. Because I have a piece of metal in here, and there's no metal over here, which means this is not lined up with the cutting surface down below. Okay? Cutting surface is down here. So to make this work, I have to find a piece of metal that is the same thickness as this other piece. Now, here's the thing. I know that this piece just came off of this piece, so they're the same. But maybe that's not the case. So I need to show you something to measure it with. This right here is a measuring disc, or it measures the gauge or thickness of metal. Okay? Now, this side of the ring, bunch of numbers, I honestly don't pay attention to that side. It's this whole number side that matters. Now, what did I do with my wire? It is not about the opening or this hole right here, okay? Those don't mean anything. it is the gap that works its way from the hole to the outside. So this right here is 12 gauge wire. So it's going to fit really good in 11. Can you see the numbers? Mm-hmm. It fits in 12. It doesn't fit in 13. Do you see that? So fits in 11, yay hooray. Fits in 12, doesn't fit in 13. It's 12 gauge wire. Same thing with copper sheet or any other sheet of metal that we have. We have for this project copper, brass, and nickel. It's like gold, silver, and bronze. So here, obviously it's not anywhere near like 15 or 16 gauge. So I'm going to come down here. 20 gauge, it fits in pretty good, but it's pretty loose. 21 fits good, pretty tight. 22 doesn't go. It's 21 gauge. So now, if I'm using the disc cutter, so I put this back in here, I want to make sure that I find another piece of metal that is 21 gauge. And that's what this is. Okay? So back to the disc cutter. What I can do here is I can move this around with my finger on the bottom. I just want to make sure that I can't see daylight through any of the sides. Like this is bad. Okay? That's what we want. Then I'll take this, it's called a shim, and I'll put it just opposite, and I'll tighten that down. Now I'm ready to cut. So I put this here on the polymer pad, and I make sure that I've got, so like this spins. You don't want this tiny thing here. I move it around so that I've got like a big chunk of steel here, and I put this here just to protect the cutting surfaces. And this has a ram that moves down as I crank this around. This right here, you've got these little plugs, and they fit, they correspond with the size of disc that you want to cut. Now, to cut, you need some dry lube here, the cut lube. You just put a little bit on the edge of that surface. This goes in here. Now, this handle it's meant to give you leverage. So it needs to be extended. I get this every once in a while, and it's like, good luck. Okay? Don't do this. It needs to be extended, and you push. Okay, so I want to make sure that my disc cutter is right underneath the ram. Now, this is a 1-inch disc, and like the maximum thickness you can put in a disc cutter is 20 gauge. This is 21. Bigger the number means smaller. So we're good, all right? So I'm just going to lean on this. It's going to make some noise, right? Then, if I look, it's still stuck. So I need to push it through just a little bit further until it breaks free. And right there is my disc. You're like, that would have been nice to know last project, right? Could have made a disc, no problem. I can't give it to you all at once, you know. All right, so there's a disc. Yay, hooray. It cuts really great. I can put this back away. Good enough. But you're remembering this, and you're saying, well, that's fine and dandy for all of these. They correspond to all these holes. What the heck are these things? Well, I'm going to show you. How many of you know what a washer is? What's a washer? Yeah, it's like, it's a disc. It's got a hole right in the middle. We can make those. You're like, or I can just go to Home Depot and buy a box of a dozen. No, it's not exactly what we're doing here. So I've got another piece of metal. I want to check and make sure that it is the same thickness as what we're expecting. 21 looks like it's going to fit. It doesn't fit in 22, so we're good. I want to cut the inside hole first. So if I come in here and say I want to cut a 1/4 inch hole in the middle of my metal here. So I've got my 1/4 hole, and I want to make sure that it's fairly close to the middle of my sheet. I put this on this side, crank it through. Now I'm cutting a much smaller amount of metal here, so it's not going to be nearly as hard. I go over to this, And right there is my 1/4 inch punch. And they're converted to millimeters as well. Get a little cut lube on there. That fits right in there. You crank it through. And there is, it's stuck. Now, I cut that out, and right now I want what's left over, so this is scrap. But your design may want a little circle, and you could actually use this, and that could be the thing that you want. Okay, so keep that in mind as well. So then I put this back. I don't want to lose it. Oh, and by the way, you see this real good? You see how this bottom half here, this is the cutter I just used, is slightly bigger than this. Don't make the mistake of putting this end in first, because then it's the cutting edge that's getting abused by the ram, and that makes it so it's not nearly as sharp. Okay, so be careful of that you're paying attention. So then I open this, take my shim out. Come on. So now I've got that hole right there in my project. Toss it around. So now let's find a circle here that we want to use. Like, so let's do I believe I can do a 7/8. So we're going to go just slightly smaller. Now, we want the little hole to be lined up with the outside circle. The little circle on the inside lined up with the big circle on the outside. We want that even space all the way around. So I've got it on the 7/8 inch, so I can grab the 7/8 inch cone here, and I put this in here. And you're like, okay, that didn't do a whole bunch, but what you want to see is on the other side actually. You see how that little cone, so like it's not, I'll push it off center here. And as I put this in here, you see how it centered it because it's got that point? Very useful, isn't it? It centers it up. Flip this around, make sure my shim is in there. Tighten this down. Take that out, please. Put this here. Apply the lubricant onto the cutting surface. Push it through. Now, sometimes that can be a little bit tricky to push that ram down. So recruit some help if you need it, but check that out. Man, having a hard time holding on to stuff. All right. That's the disc cutter. There's some other cool stuff that you can do with the disc cutter, and I want to show it to you real fast. Some of you found designs that this might apply to. So I'm going to cut a 1-inch disc. Make sure I get my shim in here. And by the way, nickel is a little harder to cut than this. But say my design and my pendant had something to do with the moon. Who knows? I can take my disc and put this back in here. We're actually going to go to the next one over here. And I'm going to put that right there. So it's just off center like that. Can you see right there? There we go. See that? What do you think's going to happen? Now I got this goofy thing that's left over, you know, thanks for nothing, right? but I've got that left over now. Eh? Save you a lot of time instead of you're trying to use a saw, huh? Nice clean edges. That's the disc cutter. Kind of useful, isn't it? Now, here's the thing with the disc cutters. Don't just say, oh, I'm going to change my design so I can use that tool. That's not how it works. Find the right tool that makes the design you want to make, okay? So we'll put that to the side, but that's how that works. Just a little thing. These are not meant to go underneath the ram. Somebody tried to, and they flattened my largest one out. It was not awesome. They're like, how come this isn't working? I'm like, because you're breaking it. Okay? If you feel like you're forcing something, chances are good that it's not going the way it's supposed to, right? So that's that. Now I want to leave the little polymer pad here because I want to show you this next one. I got a bunch of stuff in my way here. This is called a dapping block. I didn't name it. I don't know why it's called what it is. It's just what it's called. Dapping block, just right there. This little block here does some pretty dang cool stuff. If I put this here underneath the ram, say I've got my washer here, if I put this in here, I can grab one of these and I can take this and I can form that metal. I'm just moving it around in there, and you can see it's starting to take shape, right? Find a smaller thing, and you want to just make sure that the round ball here, like what you want to avoid is like this. That just dents up the end of this, abuses it like crazy. Then that same dent is transferred to everything else this thing ever touches. So you want to be careful that you're using the right one. This fits perfect like this, but when you consider that there's going to be metal in there too, that makes this too big. Okay, so if I were to put this in here, then I would want to find a smaller diameter piece. Slip? What do you mean? It will. You got to keep a hold of it. And you got the beginnings of like a, hemisphere. I can make two of these, solder them together, start making, like a little spaceship. I don't know. little flying saucer. I don't know. There's a million different things you can do. Let's see if we can you just move that piece of metal around just so you get all of it, and you can start to really get a nice shape, like a bowl. You'd be like, man, I really like cereal. You can make, no, I'm joking. Anyways, you're not gonna let them do that? I guess if cereal makes you tick, then rock and roll. Okay, now let's talk about different tools that will allow you to make some marks on materials. Okay, yeah, that's what everybody needs. So let's go back to, say I've got this little disc here that I cut. Say I want to drill a hole right through the middle of it. How would I find the middle, the exact mathematical middle of this thing? It might be kind of hard to eyeball, won't you think? You get a ruler and go from different angles. Well, there's tools for this sort of thing. Okay? This little guy right here is fabulous. Take this, it's got a little right angle here. You put that right there, and that finds that line. Now I could take this little marking tool right here, called a scribe point, and I could scratch that line in there, no problem. But it's going to be hard to see. I'm going to show you. So if I scratch that in there, can you see that? No. A little bit right there. There's a better way to do this.
Sharpie. Take
the biggest Sharpie in the world. Look at this thing. And if I just mark this, because I'm just trying the middle, so I don't need to cover it all over. This marker lives in the top toolbox, top drawer in the toolbox. Just don't dry it out, okay? Then I can put this in here once it's dry, get my scribe point, and I can scratch a line in there, and there it is. Much better, right? You're like, if it's not the glare. Then I can turn this so it's going in a different direction, different angle, and I can scratch that line in there now, and I can see the exact middle of that disc. Kind of nice, huh? You don't have to guess. So, right there, say I want to drill a hole there. Now, I can use the punch. Have I shown you guys how to use the punch? Line it up and punch it, just like if I were to punch this, you just until it pops, okay? That can dent your metal if it's thin. And so the alternative, just find a piece of, you know, like your desk or whatever, put your scribe point right where you want it to go, and just work it like you're gonna try and shove it through, but it's not gonna, doesn't need much. And you can see that little dot. Awesome. Let's drill a hole. So let's come over here, and I want to show you how to change a drill bit. So I want to use a 14 gauge drill bit, but there's a smaller drill bit in here. And you're like, how do you know what size the drill bit is? How could you figure it out? Yeah, the gauge measure. Where'd it go? It'll fit. We know how it's going. Yeah, there it is. It was blending in. So here's the drill bit that I think I want to use, because I want to use that wire that was used before. So I just want to come in here and say, yep, that is a 14 gauge drill bit. Super cool. So down here, this is the chuck key. Make sure you don't have your foot on the gas when you're trying to do this, because it'll spin.
Bad days.
Yeah, bad day. So this little nub goes in that little spot right there. And when you've got a drill bit in your hand, it is hard. Hold on to the drill bit. You take it out. This one is threaded back in. And I'm going to try and give you a non-example here. If your drill bit is not in there straight, it's going to look like this. That's not going to drill one hole, I promise you. That's going to make a giant mess, probably of lots of things. You want to make sure that the drill bit is centered. And you do that by, as it starts to get tight, you just kind of wiggle it in there. Just kind of back and forth. Make it nice and tight. You're going to test it, make sure it's not going crazy, okay? So now it's centered. Yay, hooray. Get the metal up here, and I'm going to lower this down until it lines up with that little spot that I made with the scribe point. Then I take the clamp and I'm just holding it down. Let go and just tighten it just so that it's holding it snug. Make sure it's lined up. Now, I'm going to run this, and I want you to see the chips and kind of the ribbons that come off of this. So, you got good light. So right here, it's found that little spot that I made. See the little chips? I think this is kind of a dull bit maybe. Oh, there you go. See the ribbons? That's what you want to see. You want to see that it's cutting, and it'll work its way all the way through, just like that. That's how you use this. If you're, like I've said before, if you're using, you know, dentist speed, that's not going to do anybody any good, okay? So we run that through and make sure it's nice and clean, and we can take this out. Now, when I make this cut, if I can pick it up, holy cow, come on. There is, I don't know if you can see that, see what you can do, Christian. There is a burr on the back of that. See that little burr? That doesn't make good jewelry. It does make good injuries though. It can be sharp. So we have a little tool right here. This is called a chamfer tool. Okay? A chamfer is just cutting a bevel on something. Okay? This goes in here and just give it a few of these, and it cuts that off. It makes it a nice finished edge. Can do both sides. Takes the burr off. Take a little sandpaper to it, and it's perfect. Okay? So that's what that tool is. So that's super, super good looking right there. Say this is my project and I want to attach another piece of metal to this thing. Okay? So let's find, here's a piece of brass. And say my idea is to make these two go together just like this. I want to find my scribe point. And what you can do here is just line up your pieces of metal and just scratch a little spot. Like that. Then we'll drill a hole. I think this drill bit's seen better days because it sure leaves a burr like no other. Cut that burr off. As luck would have it, I have a piece of sandpaper here. That's weird. Sand that side off so it's nice and flat. Do the same thing with my other one. I want to take all those scratches and things off. And it's the same as if you used the sandpaper before. Use the 320 grit sandpaper. It's always labeled on the back. 320, and the other is 600. Use the 320 first. Then the 600. Okay, so now I've got those two nice and lined up, and they'll work. So now, let's come back over here. Okay, all my scraps. Don't throw those away, by the way. Put them in that box for recycling. This little block here is in that big, long, wide drawer in the toolbox. And there's a bunch of hammers in there. And this is like the cutest hammer you've ever seen. This guy right here. This is tiny. Super effective, really great. This one here, slightly larger, just different shape. This one's still got a rounded end, okay? But then the radius here is much more gentle, all right? Where this one right here is flat. So just different hammers for different things. This little block is called an anvil. And what we're gonna do here is, and I've left tools, scribe point. I'm gonna take my 14 gauge, 12 gauge wire, and the ends are kind of smashed, so I need to clean them up. They don't quite fit. Take these cutters and trim the end off, but also sandpaper. Sorry. A lot of times, so this wire I got from when I was remodeling my house. This is wire that you buy at Home Depot to wire your house. Take the insulation off. And what I need to do is I need to sand the end here just to take it down just a little bit. So it's not like really precision. It's close, but not completely there. I just need to take a little bit of material off so that it will fit through this hole real tight. Okay, we're not quite there. You can take a scribe point and gently make these so that they fit nice and snug. We're almost there. And what we're going to do here is I'm going to make something called a rivet. And a rivet is like a metal pin that then is has like a bookend type effect. And I will show you how we're going to use a rivet to make these fit. Now, I'd rather that this hole be too big than too small. So that is just right. I don't want it to be real sloppy in there. Otherwise, it's not going to work, like at all. Okay? So that is just right, and this one is not. So we need to adjust this one here too. This is just increasing the diameter of that just ever so slightly. Yeah. Good question. The question was, drilling the hole too small is okay, but too big is not okay. It's just like, you know, in wood shop, when you cut the board too small, you can't stretch it, okay? So I'm taking some out, I'm making it a little bit bigger, and I'm making fine-tune adjustments until it's the right size. But when it's too small, or when it becomes too big, you can't fix it. Kind of like going and getting your hair cut and having them take too much off. Trust me, I know how that goes. Okay, you just, thanks for laughing, those of you.
If I make it too big, is there a way to fix it?
No. You have to find a new piece of wire that's bigger, and you have to re-drill the hole. So there is a way, but if that's not an option for your design, then we're not there yet, Mr. Cameraman. There are other ways to fix it, but it's not with a rivet. So now we're there. I've got them through. The one pin is through both pieces of metal. So now what I need to do is, I've already got this cut with the flush cutters, and I want that to just stick out just like a millimeter. You get a view of that. You just barely sticking out the edge there. Then on this side, I'm going to trim it flat so that there's an equal amount sticking out on that side. So now I've got this little pin. You got the right camera angle for that?
Yeah, just see. Hold right there.
Yep. And you see that on both sides, folks? That little piece of wire sticking out on either side. So now I'm going to line up on this anvil, and I need to hammer this thing. Now, if I hit out here on the side of the metal first, what happens is the metal goes all the way down to the anvil, and then my pin is only on one side. I need equal bits on either side. So it needs to be centered, so when I put my pin on the anvil, okay, I'm going to hit the pin and not out here. Now, here's like a pro tip for you. Get your elbow on the table that's holding the hammer, okay? And when I do this, I've got my elbow here, then you use it kind of as like a pivot, okay? And you can go up and down in exactly the same place, okay? Now what's happening, what's like a really magical thing that's happening here, is the first couple little taps you make, it's actually crushing that pin and it's making it fill up the hole. And it's expanding it and it's binding it in there. So I'm using the rounded side, the ball peen side, and I'm going to flip this over. And I'm going to do the same thing. I flip it over. Now we're not framing a house, you're not driving a nail in a board, you're not hitting it real hard, it's just lightly tapping it. Flip it around. I can flip this to the flat side. Flatten it out if you want. And now, where'd you go?
I'm on the side of you now.
Okay. Now those two pieces of metal are stuck together. Kelsey.
Why use the round side versus the flat side?
Good question. If I start out with the flat side, you can catch that edge, okay? And you can put like a crescent circle, okay? Because you're starting out hitting it harder. And if I come out here, like if I take this scrap piece of metal, and if I hit it like that, I don't know if you can see that. Do your best. That would take, see that little dent? That's what the flat side will do if you get too crazy with it. Now, in contrast, the ball peen side will make its own version of a dent, okay? That's why I'm telling you to anchor your elbow to the desk, and if you need to get a short blue chair from the ceramic side of the classroom, the more obviously ceramic side of the classroom, over there, then you can sit lower and you can make you can hammer. You don't have to switch to the flat side, but now let's take this and I'm going to put you back in here because I'm going to draw you a picture. So, drawing a picture of what we just did. Here's two sheets of metal sandwiched together, okay? And what we did is we drilled a hole and we measured and made sure that our wire and the drill bit are the same size. Everybody up to speed with that one? So this is the hole is drilled here. I'm going to explain another type of rivet, but I'm not going to demo it because it's going to look exactly the same. So I put my pin through. It's protruding out either side just a little bit. Okay. I put my anvil here. And I hit with my hammer right here. Here's my hammer. I'm hitting right here, right in the center. And that crushes this pin and makes it fill up here and binds it, makes it real tight. Then what happens is I start to flip this over, and as I start to hit, this material right here starts to flatten out. And it actually changes shape, and it's like this. You see how that acts as a little clamp and is holding the metal together? That's what happened with this. Now, you see how this side, I hit it with a hammer, hit it with the flat side, and it flattened that out. If you like the texture of those little hits from the ball peen side, that's really cool. Now, I wouldn't attach this, I wouldn't sand it. You know, I'd sand it before and then hammer it, and then you can polish it and it'll look really super cool. But if your design, if you don't like having that little thing sticking out there that you can feel, there's another way to make a rivet. And that's what's called doing a blind rivet, where you drill this hole, same as before. But then you'd take that chamfer tool, this guy, and you'd run it in here, and it would cut, and you'd do it a little bit more than just cleaning off a burr. You'd cut these, then you could put your pin in here, okay, hammer it, and what happens is all this material up here squishes down into those open voids, and it's straight across, but you're still clamping onto something. Now what's really cool about this is say you're using copper sheet and you use a copper wire, and as long as you get that completely filled, you can sand it off and it doesn't look like anything's there at all. It's blind. Or you can use, say, copper sheet and a nickel pin, and you have like a little silver dot that you can't feel, but you can see it. And everybody's going to be like, how'd you do that? And you'd be like, because I'm just awesome. Don't ask questions. Okay? I don't know. This is a rivet. This is what's called the cold connection. There's another cold connection I want to tell you about. So we're just moving right along. Say you've got this super cool design. It's a squarish rectangle thing, because nobody's ever made one of those before. Look at this. This is me and my rectangles. Okay? Nobody's ever made those before. And say you want to cut an opening. You guys know how to do that with a saw. And then you want to suspend another piece of metal in here. Well, I could drill a hole there, and here, and here, and say here, and here, and here, and here, and here, and here, and here. And you could take really thin wire, like 30 gauge wire, or 28 gauge wire, can't remember what we have. And you could run wire and like twist it. You see what's going on? You can use wire and use it almost like, well, you could like sew with it, sort of. Say you had two pieces like this, and you wanted to attach them together. They were the same. You could drill holes around the outside edge through both sheets, and then wrap it around like you're sewing, like needle and thread. that also functions as an effective cold connection. All right. Now, the opposite, hot connections, is where you're soldering. And that's the video that you'll watch in the copper soldering assignment. Okay? Now, there's a couple other tools that I want to show you. Nat, you want to be the camera person this time? Or is Christian going to feel bad for not doing it? We'll let his knees feel better. Do what?
He needs to sit.
Okay, so the camera is down in that corner. All right. Here is, I might need to cut another strip. Hang on. I'll be right with you.
All right.
Okay, let's look at this thing. This is officially, I just got it. It's a ring bending tool. This thing can be pretty dang cool if you want to try it. Officially, my first chance at this was yesterday. My 8A TAs wouldn't share. They were having way too much fun with it. But so these little contraptions right here, they're like little, I don't know, like a mold or whatever. They will shape your material. So like this is square. This is a 90-degree square. We can put this in here, and then this is going to match up very well with that. You slide this in here, and then take your material like this, and it helps if you make sound effects. Come on. Oh, sorry. You disappointed in me? Right.
Oh, I need to be quiet.
No. Trying to make a square, it's not working. There we go. What? I did, yeah. And then I can trim that. And it's going to start to, and I can cut that with a saw. I can fine tune it in here. But keep in mind, this is a metal piece and it will mar or mark up your metal. We have, if you're making round bits, so like let's do this 18 millimeter here. I have, these are called Delrin. And Delrin is a hard material that will not mangle your work. Okay. All right, we're gonna see if we can straighten this out. This will be fun. And I'm trying to capitalize on one piece of metal here. See what's going on with that one? All right. That's another tool that we have that can help you manipulate sheet metal and other such things. Okay? Now let's go just next door here. This little thing is pretty dang cool. Say you wanted to make a bunch of loops. Say you wanted to make your own chain. That could be cool. Might take some time, but it might be cool. All of these are different diameters. And if I want to take my 14 gauge wire here, or 12 gauge wire, all this is just like a chuck in any drill. You tighten that down. Some of these have a little hole. that you can put your wire in, okay? And then all you have to do is just crank it around, make sure there's nothing in the way. Now you get to the end of your wire, don't drag it across the tip of your finger, it will cut you open. Okay? I know, right? So then you can take this out. Cut this off. Okay, then let's go over here to the bench real quick. My bench. And I'll show you what you can do. Get your saw. And make sure it's attached correctly. Oh my gosh. You take this. So there's a piece. And to see what happens, I'm not going to take the time to cut all of it, but you can see it's all falling apart. It's because there's a recording going. Now I've got potentially a lot of these little rings in there, all exactly the same size. I could link them together, I could stretch them, I could do whatever I wanted with them. It could be really dang cool. All right? All right, let's take a look at this here. Thank you, Nat. There is one last little tool that I want to show you that is really, really nice. So what I'm going to do here, say I wanted to make, let's use this piece of brass right here. Say I wanted to get 4 rivets, like really precisely in a particular spot right in the corners of this thing. So I take my Sharpie. I want to show you how to use this last little tool. I cannot hold on to anything today. Okay. This little guy is called a divider. And a divider is just like it's probably the most precision tool we have if used correctly. You tighten this down and the space gets smaller. You loosen it, it gets bigger. And what you can do, you take this, run one side down the edge of the material and scratch with the other, and I can get the same distance around. See what I've done there? Then I could take my scribe point and I could mark each intersection. I could push real hard and get a little dot, and then I could drill holes and they would be precisely placed all the way around. All right. Here's another measurement tool, if I can, seriously. This little guy here is really pretty cool. This, you see, is in millimeters, but those are way bigger than millimeters. What's happening here is you can put a piece of metal inside these jaws, and it will tell you how thick it is because it's graduated up. This is like 0.8 or 0.85 millimeters thick. You're like, okay, that's neat. We already have a thing that's going to tell us the thickness of something in gauge. Why would we need to know that? This is something that you're going to need to remember. Right here on a jeweler's ruler, there's this note right here. Add 3 times the metal thickness to a ring or bracelet measurement as it's shown. So here's the ring shank side. So a ring, okay, if I take a ring and I cut it and then straighten it out, this is a size 9.5. This would then be that long. Pretty cool, right? But if I take like my wire that I curved around everything, if I were to cut something that's 9.5, that's size 9.5 length, and then make it round, the outside diameter would be the 9.5. The inside would be like an 8. This is entirely the wrong size. So you have to consider the thickness of the metal so that it's the inside diameter. So that's why this tool is important, is it allows us to measure the thickness of stuff, right? Whatever. Now, there's another one we have. This one is, if you're really trying to be an overachiever and super accurate, we have a digital caliper, okay? And this will measure in millimeters. It will measure in inches, and it will give you a fraction. But it does it for you. It's just push a button. I know, right? I know. So that's another option too. What's nice about this is you can use these, the other side for the, so like millimeters. 19 millimeters in diameter. Kind of cool. Anyways, that is, I think, let me check my notes and make sure that I've covered everything I wanted to, because there was a whole bunch, as you can tell. Oh my gosh. Just about forgot. Nat, I need you one more time. We're going to end on a good note. Nat, I need you one more time. All right, we're going to do the rolling mill. So, this guy right here. Come on over here. So, this. Some of you have looked at it and you're like, I want to know what that is. This is a quarter, and this quarter's seen its last days as a quarter. We're going to show you what this thing does. All right, it's going to be kind of exciting. If this thing is not set up, this key should live somewhere else. It's going to live. You can just look up here. The camera can stay, but it's going to live right up there. Okay. The reason why we put it away is so folks don't run clay through it. Because that's bad. But this goes in here, right? And this moves both of these at the same time, which is super cool. Now, righty-tighty, lefty-loosey does not work with this. It's righty-loosey, lefty-tighty. Wrap your head around that one, right? So, if you're the first one to use this, and the key was put away, well, and I would do this every time, you need to calibrate this thing. So we're going to get down low so we can see, we can look through here. So if you look under here, you see that little sliver of white, or a sliver of light that's right in there? If I put the key back in and you watch that, if I cinch it down and the thing disappears when the rollers touch, then you're good. But what happens is sometimes one side gets moved, and then the other, and then the key goes in, and when you tighten it down, you see how that's tightened because it's touching over here, but there's still a gap over here. So your metal that you run through is just going to get mangled. It's not going to do anything good. Okay, so what you have to do is tighten these down until you get no sliver of light through there. Okay, then I can open this up. So now I go open as much as you can, and you just put your piece of metal in there and then tighten it down until it touches. Right there like that. Now I'm going to open it, roll the handle towards me. Then I'm going to tighten this 1/2 turn. Now the metal doesn't want to go through. I crank the handle and it'll dump it out the other side, and you can see nothing really much has happened. But what's happened is it's flattened the outside edge of the face of the coin, because that's actually the widest part, is the outside edge. But then if I go another 1/2 turn, things start to get a little more interesting. Now the thing is completely flat. There is no more. Old George is completely gone. Sorry, George. Another about third. If you go a 1/2 turn, sometimes it gets way too much pressure. We're going to keep going in the same direction. See what's happening? About a 1/4 turn. Not like a quarter turn, but like, you get it. Okay. Oh yeah. Oh yeah. Again, if you're forcing it, you got too much pressure. All right. That's some sad news for you. This doesn't work in the vending machine anymore. Oh. It's wanting to turn on me. It's not going to work. Anyways, it's pretty dang. It starts to get really flimsy. This can really give you a sharp edge, and it can cut you. So be careful with this. Now, I had a good question. What's the deal with these grooves? You can come around here so you can see the grooves. Well, if you took some round wire and you find, so you got to have this thing shut. Okay, not like tight, but just barely. And see how that'll fit through there, but doesn't fit through there. You can send it through this right here. And then run it through the next smaller one. And what it's doing, can't quite tell yet, so hang tight. Is you can make round wire square. So you can see kind of the flat surfaces as they shine in the light. It's hard to see, but you can make it square. That can be something that you do. Okay? Just be careful, if you squish it too much, you start to get little fins off of the edge of the square, and they're razor sharp. So just make sure that you're not doing it too much. But that is what those grooves do. Okay? I believe that's everything. So, good job. Thanks for listening, folks. And watch the video of the copper soldering, okay?